Okay, let's get right into it. For decades, the entire world of electronics, everything from your phone to a supercomputer, was built on just three fundamental pillars. But what if I told you there was a fourth, a missing piece that could completely flip how our computers think, remember, and even learn? Well, that missing piece has a name, the memristor. And it's getting ready to redefine, well, pretty much everything we thought we knew about computing. At the very heart of this whole thing is one simple but really powerful question. What if a tiny part of a circuit could remember its own past? Remember what happened to it, even after you cut the power. It sounds a little like science fiction, right? But it's the key that could unlock a whole new era of technology. So, to really get why the memristor is such a big deal, we have to rewind a bit. We got to go back to the basic building blocks of every single electronic device you have ever used. For the longest time, everybody thought we had the complete set. Turns out we didn't. So take a look at this. This table kind of lays out the beautiful, elegant symmetry of electronics. You've got the resistor, which connects voltage and current. You have the capacitor, which connects voltage and charge. And then there's the inductor, linking current and magnetic flux. But, see that blank spot, that question mark? For decades, that was a theoretical hole in the blueprint of electronics. There was just nothing that directly linked charge and magnetic flux. It was just missing. Now, this missing link was first dreamed up way back in 1971. A professor at UC Berkeley, Leon Schwa, he argued, purely from math, by the way, that this fourth element had to exist for everything to be symmetrical. But for almost 40 years, it was just an idea on a blackboard, a ghost in the machine. And then bam, in 2008, a team at HP Labs announced they'd finally built one. They turned a decades-long mystery into a real physical thing. So what is this breakthrough device that finally filled that gap? They called it the memristor. It's a pretty simple name for an idea that is absolutely revolutionary. So let's break down what it actually is. The name itself is the perfect explanation, really. It's just a mashup of memory and resistor. And that's exactly what it is. At its core, it's a special kind of resistor. But it has this incredible trick up its sleeve. It remembers the history of the electricity that's flowed through it. So how does it remember? Well, the concept is surprisingly straightforward. If you send a current through it one way, its resistance goes down. If you reverse that current, the resistance goes up. But here's the magic trick. When you turn off the power, it doesn't reset. It just holds on to whatever its last resistance level was. It freezes that state in place. And that right there is its superpower. Its memory is what we call non-volatile. Think about the RAM in your computer. The second you shut it down, poof, everything's gone. A memristor is the opposite. It holds its information forever, with absolutely zero power. Okay, so this unique ability to both act as a resistor and to remember its own state allows the memristor to do something absolutely radical. It can merge two functions that, in every computer ever built until now, have been kept totally separate: memory and processing. Just look at this comparison, because it gets right to the heart of a huge problem in modern computing. In basically any computer today, you have the processor over here and the memory way over there. Data has to constantly get shipped back and forth, back and forth. It creates this massive traffic jam that wastes a ton of time and energy. We call it a bottleneck. But with memristors, the computation can happen right where the data is already stored. The traffic jam just disappears. This whole new way of thinking is a total game changer, and it has a name: in-memory computing. And this isn't just a small improvement, it's a fundamental rethinking of how you even build a computer from the ground up. And this is where it gets really, really exciting. This behavior is incredibly similar to how our own brains work. The connections between our neurons, the synapses, they get stronger or weaker depending on the signals they get. That's literally how we learn. And memristors can do the exact same thing, but on a piece of silicon. So what does a future that's powered by this kind of brain-like hardware actually look like? Well, this is where science fiction really starts to feel like science fact. I mean, we're talking about things like neuromorphic chips, computer chips that are actually structured like a brain, that can learn and adapt all on their own. Or imagine instant-on computers. No more booting up, you just open your laptop and it's exactly where you left it, instantly. We could build incredibly efficient AI that learns directly in its hardware, and maybe, just maybe, create data centers that use a tiny fraction of the energy they do today. Now, of course, a revolution this massive doesn't just happen overnight. there is still some pretty big challenges to tackle before Memristors are in every phone and laptop we own. The biggest hurdles are really practical ones. I mean, figuring out how to manufacture billions, even trillions of these tiny, tiny components with perfect consistency, that's a huge engineering problem. And you can't just drop them into today's chip designs. The whole architecture needs to be rethought. But even with those challenges, it's really important to remember what we're looking at here. The Memristor isn't just a slightly better transistor or a faster kind of memory chip. No, it represents a true paradigm shift. It's a chance to build computers that aren't just faster or more efficient, but that are fundamentally, well, smarter. Which brings us to one final, really profound question to think about. By creating an electronic part that works like the synapses in a human brain, are we on the edge of finally teaching our machines not just to calculate, but to actually think?